Today the topic of discussion is in singly circular linked list you will see the insert middle function, that is how to insert a node not at the beginning, not at the end, but somewhere in middle. Fine. So prior to this we have seen the video of how to create singly circular linked list, and in that we have seen menu also. We have seen the video of how to print element of linked list, and prior to this video we have seen insert also, insert beginning, how to insert a node at beginning of linked list. Now you will see insert a node at the middle somewhere, not at last, not at beginning, somewhere in middle. Fine. Okay, so you have an option now in middle. In insert you have options now that you can insert at beginning, that is for if you press 1 you can insert at beginning, if you press 2 you can insert in middle, if you press 3 then you can insert at end, but my job is to insert at middle. So what I'll do, I'll press 2, switch will have 2, case 2 it will jump to case 2, and case 2 we are calling a function insert mid, and you have already a linked list. You can see a linked list, and somewhere in middle, that is not at beginning, not at end, somewhere in middle you have to insert a node. Fine. So let's start. So here you have a function of insert mid, and here we have created a pointer temp and current, both are of type node1. What is node1? I have already told you many time in every video. This node1 is actually, we have created a structure. For creating a linked list you have to create a structure. I have created a structure of type node having 2-part data and 1 address, and I have created a variable of this structure which is node1, and I have type defined it. So by using type def, now entire structure is represented by node1. Okay, so instead of writing struct node, I can use only node1. If you have not used type def, then every place you are watching node1 you have to write struct node, everywhere you have to write struct node. Fine. So in order to simplify the code, I have type defined it. Fine. So let's see the coding now fast. So you have a linked list, and suppose here at 4th position you want to insert a node. Fine. What you will do, first of all, if you want to insert, you have to create a node. So you have created a pointer, current, initialized with head is 100, so current will come to the 100. Fine. Okay, fine. So you have created a variable position, that is you will ask user which position, and you have created a variable I is equal to 1. So you have a position variable and you have a variable I is equal to 1. So let's see. First of all, I have asked malloc to create a node, and return that address to temp. This is what I'm not going to explain you. I have already explained you many times. Fine. So this malloc, what will malloc do? It will create a node of node1 type. So it will create a node of node1 type. So I'm already creating at 4th position. Fine. So this is, suppose the address of this is 600 and the name of this node will be temp. Fine. Since I've created a node, I have to insert a data. Again, I'm asking user enter the data. Suppose he has inserted 10. So what will happen in position? Temp data will have 10. So temp data will have 10. Fine. Okay. Now I'm asking user to enter the position. Since I've already by default taken is 4, but I have to ask the user enter the position. Now suppose user has entered 4. So position will have 4. So again, I'll use this coding. I have already used this coding in previous videos. So if you have seen my video of singly linked list, you can have a good understanding of that. But again, I'll explain. Now comes the question that while position is not equal to 1, I plus 1, position is what? 4. What is I plus 1 is what? 1. 1 plus 1, 2. Since 4 is not equal to 2, yes, condition is true. 4 is not equal to 2, condition becomes true. I'll move inside and I'll update current. Current will have current next. What is there in current next? 200. So current will move from this place to this place. Fine. Okay. Again, what I'll do, I'll increment I. So I'll become 2. I'll not come out. I'll again check the condition. Is position is fixed. 4 is not equal to I plus 1. Now I become 2. 2 plus 1. 4 is not equal to 2 plus 1. Yes, 4 is not equal to 2. 4 is not equal to 3. Condition true. I'll again go and again update current. Current will have current next. What is current next? 300. So current will move from this place to this place. Fine. Again, I'll increment I. I will become 3. Again, I'll go to the while loop and check is position is fixed. 4 is not equal to 3 plus 1. Is 4 not equal to 3 plus 1? Is 4 not equal to 4? No, 4 is equal to 4. Condition become false. I'll come out of the loop. So I have come out of the loop. Finally, I have come out of the loop. Now what will happen? The moment this what will happen actually? Current has actually reached to the position, after which I have to insert a node. So this coding is actually taking a current to the position, after which you have to insert a node or you have to delete a node. Since we are inserting, so we'll talk about insert. So current has came just prior to the node where I have to insert, after which I have to insert. So if you see the understanding, if this node is going to come in between of these two nodes, then the address which current is holding will be holded by this, because current is holding the address of this node. But the moment this temp will come in between of that, temp will keep the address. So what temp will say to the current, current kindly give me your address, because your next address I'll have to keep that. So temp next will have current next. What is current next? 400. So what will come over here? 400. So this node will start pointing this node. Currently, if I talk, these both the node are pointing to the same node, but current will have to point this. So what will happen? Current next will have temp. What is there in temp? 600. So what will come here? 600. 600. So this connectivity will get broken, and finally this node will come in between. So this is what actually coding is all about. And if I tell you the important part, first of all, try to connect temp first and then current. If you will swap the order, that is, if this is coming second time and this is coming first, that is, I've swapped the coding, then definitely you will not be able to connect the node. And I request you to kindly take it as a homework and do it, and you will understand the coding. Now I'll rub all these things and show you how things are taking place. So this is actually the things are taking place. Now this temp will keep the address of this current will take the address of this. Now this will get disconnected. Simply this is what happened. And at last what will happen? This 12 will take the position between 7 and 8, and see, you can see the 12 is taking the position in between 7 and 8. That is, 12 is taking the fourth position. 12 is taking 5. This is 4. I'm so sorry. So there is also one node. There is also one node, fourth, and having address suppose 200. So this is very easy. You need not to worry about this. So suppose you forget this. No, you have this and you have inserted. So finally 12 will get inserted. No, at fifth position. It's a fifth. If it's fifth position, I'm so sorry for this, because I took this as an example, and this node is having a fourth. So the same coding will work. Need not to worry about that. What is actually taking place? You just make this position now fifth and start continuing with the coding. I've used the wrong figure, so you will understand what this coding is doing actually. Fine.